So, very good afternoon to you all. Myself Mayank, and today I'm going to present my presentation on the topic of living space energy efficiency monitoring system. So, here I will present my presentation on the under the course of PHN 310 applied instrumentation. So, let's begin. So in this contents, I will go stepwise. First, I will introduce the theme of living space energy efficiency monitoring system, and I will provide some overview on current and voltage sensors. Then I will calculate the power consumption. Then after integrating with mobile application using electrical connections and setup, I will give some data analysis which ultimately we can provide some insight on that. So here let's begin. So for understanding this living space energy efficiency monitoring system, here we can think about the energy wastage in our house, like in our daily life. We forgot to turn off our electrical appliances after using them, like in our in home in different parts of a living area. We forget sometimes to turn off the kettle, we turn off fan, uh, cooler or some heaters, etc. So from that, a lot of energy wastage is here going. So we can from in this project we are using some devices, some sensors, voltage and current sensors, so that it can provide some insight on the power consumption using power equal to V into I. So from that it will provide the energy consumptions in different areas of our home. From that we can analyze the total wastage, which from and after analyzing this we can understand what kind of wastage of electricity is going on. So here we will use the current sensors, voltage sensors, and from that we can in current sensor we will use Hall effect sensors to measure the electrical current flowing through the circuits with high accuracy and wide measurement ranges. So here in Hall effect sensor, uh, it is a we I think we are most are the we most are familiar with this Hall effect sensor principle. So here what happened in a semiconductor, when the current flows in a direction, then if we applied magnetic field perpendicular to the direction of current, then the charge separation will take place, and from that charge separation, potential difference will be created inside the semiconductor. So from that, this potential difference will called Hall voltage. So using this formula here, here in this formula, V Hall equal to RH dot I dot V upon D. So if we got all those components, Hall voltage and D means here the dimensions of that semiconductor device. So from that we can conclude, we can find out the current here. So using this Hall effect sensor principle, we can find out the current, we can sense the current, we can measure the current throughout the circuit, which is more effectively we can calibrate because it is more accurate. Hall effect sensors has high accuracy for finding currents. So these are some properties of current sensors and voltage sensors. But here one point to remember, like we can find current and voltage using other sensors also. Like in current sensor, we can use Hall effect sensor. Yeah, we are using here. But for we can also for high current applications, we can use current transformers also, which can which because which it offers isolated measurement for high current applications. And in voltage sensors, what we will use, we can use simple capacitive sensors also, IC sensors also. There are some advantage of IC sensor which will provide more accurate and compact voltage measurement with signal conditioning. Then if we have all those sensors, then what we will do, we will set up those, we will install those sensors in different part of the circuits in our home, like in our home, and different wires in our home, so ensuring safe and secure connections with. So then first we will use sensor wiring, we will do sensor wiring, then system integration, then calibration finally. So we perform through calibration to ensure the system provides accurate and reliable energy consumption data. Then finally, after when we got all those information, that what is the current in this circuit and what is the voltage in this circuit, then we can finally by this providing by this real time data, we can use this formula P equal to VI to calculate the instantaneous power consumption for each monitored circuit. Okay, then same through the like voltage measurement and current measurement using RMS voltage value and this using this current value, we can use this formula to compute the power consumption for each monitored circuit, which is divided throughout the different parts of our home. Then this data using we can use Arduino here. So by using this data will be it will be connected to the mobile app application. So we will use our home's Wi-Fi network for some good internet data so that we can collect those data transitions to the mobile application, and from that data we can calculate the power consumption of electricity in different parts of our home. So uh, our like we can our sophisticated algorithms which will analyze our energy consumption patterns, which offer personalized recommendation to optimize our usage. And for remote monitoring, we will access our home's energy data anytime, anywhere. It will allow us to monitor and manage our electricity usage on the go. So this is the benefit of our mobile application. Like using all this data, mathematical data, we will use our mobile application. Like if we are traveling somewhere and we can find out that if by mistake and if I have forgot to turn off the light, or if I have forgot to turn off the fan or something critical appliances, I can check this through the mobile application. So it will very useful for that. To understand to pick up those power consumption, power wastage. We can control those power wastage by using mobile applications. So we can use this. This is the benefit of mobile application integration in this project. And from that we can identify, and using those mobile applications we can identify energy waste. Uh, so I can tell you how we can predict those electricity wastage, or how we can highlight those wastage. Because let's say uh, in this mobile application, the whole data of voltage and current, whole data of power consumption will be in the in many forms, like graphical way on the scale of 100. For example, on the scale of 100, if there are 4 rooms in our house, and for each room, if the 25%, for example, for each room 25% of electricity is divided, and if in all 3 rooms there are 10% electricity is consuming, and 5% in second room, and 7% in third room, and 22% in last room. Then from that we can conclude, we can predict that there is something wrong in the fourth room, something like anything by mistake, and some electrical appliances uh, maybe on the it will waste, it is wasting our energy. So from that we can identify the energy waste for this. There are 4 ways also, like automatically generated anomaly detection, where our advanced algorithms will identify the abnormal power consumption patterns. Like there are some patterns, like in our home, usually there are some patterns of power consumption, but in certain days, a certain time, if it changes drastically, then we can detect those power consumption. And this behavior analysis, like using some household usage trends, which will provide tailored recommendation to optimize our energy consumption. This mobile application will give a clear data-driven insight, empowering us to make informed decisions and implement energy-saving measures. There are some points we have to take care of this, like data backup, electrical inspection, software update, sensor calibration, so that we have to by time to time we have to update our software, and we also have to check the electrical appliances, electrical inspection, to avoid any, like to prepare for any safety or performance issues. And we also have to ensure that our energy usage records are always available and it is protected. So that's, and sustainable energy management. Here, these 3 things, like smart home automation, energy conservation, and renewable energy integration, which which we can also in further in future we can explore opportunities to connect this the system with smart home devices, which can enable automatic energy saving actions based on energy conservation. So for contributing to a greener and more sustainable living environment, we can utilize the system insight to implement long-term energy efficient practices. So this which integrate the monitoring system with renewable energy sources such as solar panel. We can also use solar panel to track the impact of our sustainable energy initiative. Like if we are using solar panel, then we can optimize midway between the usage of solar panel and using of primary electricity sources, normal electricity sources, so that we can also use this renewable energy options here. So, and by using some smart home automations, smart home devices, like we can use some we can, like in this slide I want to present the how we can expand our application our application software, so that it can move towards more smart home automation techniques. Like for example, if we are traveling outside and found our using our if we forget some electrical appliances to turn off, then we can now use our mobile application to, from that mobile application we can control our whole electrical devices in our home, so that from using this mobile application we can turn off any electrical appliances. So it will contribute to a more greener and more sustainable living environment. This this energy monitoring has a huge future. We can explore some opportunities also to integrate energy storage solutions such as batteries, and we can also use some Internet of Things uh, fundamentals to give the system which we can connect the monitoring system with a wide range of these IoT devices, which can enable comprehensive energy management across our smart entire smart home. So overall, in this presentation, the conclusion is that we can like by implementing this our living space energy efficiency monitoring system, with we will gain the unprecedented visibility into our home's energy consumption. So we can make some informed decision and pre-informed decision, so that we can optimize our energy, and we can optimize our energy by reducing the wastage, and from finally we can contribute to a more sustainable future from that. So this was all. Thank you for your attention.